And I would like to hand over to the next guest at this time, who is Daniel Hrtus from Orlen UniCRE, whose presentation concerns the chemical recycling of plastics. Daniel, please, stage is yours.
Thank you, Peter, for the intro. So maybe just a brief introduction of who we are. Orlen UniCRE, we are a R&D institution in the oil and gas or refining and petrochemical industry. Of course, part of the Orlen Capital Group, the biggest refining group in our region. And we are based out of the Litvinov refinery. And we work, although we are an independent research institution, we work closely with the Orlen Unipetrol. And so much of the research we do here, we can directly apply to the industrial scale, which is a huge advantage. Now, the topic of my talk is chemical recycling. Much like alternative fuels, it is quite a hot topic right now, as we are walking towards decarbonization, and this is concerning, yes, reduction of emissions, but also a more efficient and sustainable use of our waste streams, which for the future is going to be a huge challenge. Now, to start, we should lay out what the situation is within the European region with recycling. Now, we produce, relatively quite a lot of waste. This graph is out of a recent study that came out. It was quite comprehensive and collected the most recent data on waste collection. And you might be surprised to see, we could call it an abysmal number, the circular solutions, or in other words, a true recycling of our waste. We actually recycle only 14% of plastic waste. And so, of course, there is a room for improvement, and it begs the question of what do we actually do with our waste. And so you can see, and much of it is incinerated to produce energy, and the second largest group is actually landfilling. We do export some of our waste, but all these solutions are what's called a linear system, or a linear solution, meaning you don't actually truly recycle the waste. It has a linear life cycle, or life stream, so to speak. So the circular solutions are mechanical and chemical recycling. I will talk a bit more about both, but the focus here is the chemical recycling. Luckily, we see that this new approach is getting traction. Many of the big players are investing billions of dollars into new technologies. So the prospect of getting it up to speed is there. Now, what do we as oil and gas and petrochemical companies, how can we contribute to circularity? Definitely, there's multiple pathways. It has been said here before that there's no one single, silver bullet solution. And with these numbers, you can see that the chemical recycling is still in its infancy in terms of industrial use. Now, the legislation and, of course, the situation we find ourselves in as a society is going to require us to reduce landfilling, reduce incineration. And so by replacing incineration of plastics, for example, with chemical recycling, we can actually save around 50% of greenhouse gas emissions, so mostly CO2 there. So the challenge here, or the goal here, is to reduce landfilling plus incineration and use the waste streams more efficiently. Now, when we talk about the different recycling methods, the way that we, the usual way of recycling, it's what's called a mechanical recycling, where you only change the physical properties of the plastic. So picture a PET bottle that you throw into the yellow bin, you melt it and you reuse it in either or the same kind of product where you have to mix in some portion of the virgin polymer, or you can, use it for flower pots, for whatever other plastic material, with the important point here being that the final product or the recycled product usually has lesser value than the original one. And so this is what's called downcycling. And it limits the number of uses or number of, recyclings you can do. Chemical recycling, on the other hand, offers maybe an alternative to this by using change in chemical structure and offering the product that can be used to actually upcycle the waste stream. You can see here that the product of chemical recycling is feedstock for production of chemicals and plastics again. And so just to give you a picture of what the waste stream looks like, these are the most common polymers you can find in the plastic waste. And so here we have polyethylene, polypropylene. That's going to be all your food packaging, the foils we throw out. You have PETs, which are perfectly fine for mechanical recycling, and then you have some more complicated polymers to recycle. PVC, for example, being one of them. And so when I talk about the circle or circular economy, what does it actually mean? The scenario right now is a production of plastics from plastics. That's how you picture closing of a circle. So it starts with collection of waste. Here we are talking about post-consumer waste. So whatever we as consumers throw out inside hopefully the yellow bins, those get collected and we can process them mechanically. And then it goes into what's called a pyrolysis plant or pyrolysis technology, which is in simple terms just a thermal and chemical decomposition with the absence of oxygen. And we get our products. We have a gas product, we have a liquid product, and we have some solid products. Now, what we are trying to do is maximize the liquid yield, because these liquids can be actually, after they have been cleaned, they can be used in the petrochemical complex, much like we have over here, to produce new chemicals. So the goal here is, with the technology, to maximize this oil or liquid production. Of course, you will never avoid some byproducts in all industrial processes. And so you'll get some gas which has high caloric or heating value. It can potentially be used for production of chemicals, but mostly it's going to be used for energy production. Depending on the technology, it can sustain the pyrolysis technology itself. And lastly, we have what's called the char, or the solid product that's left as the third byproduct. And luckily, there's not much of it. We don't have much use for it as of right now. We're looking into it as a matter of research, but the focus here is absolutely on the oils. Now, if I were to give this talk 2 years back, the picture would be production of fuels from this. In terms of legislation, right now, there's the only viable way for us is to use it some other way than actually burning it, whether it be incinerators or whether it be in engines. And so making some valuable products, this is the future for chemical recycling, the more sustainable future. And this is not talking down on the other alternative fuels. We absolutely do need them. It's just that the original idea here was, yes, producing fuels, but when you look at the legislation in the EU, it's going to support production of new chemicals. One of the biggest challenges here is that the waste streams we produce are quite contaminated. Now, pyrolysis has an advantage that it's quite contaminant resistant. However, we still need to clean the feed. And so we did we looked at the stream composition of plastic waste. So picture the yellow bin, getting into a sorting facility. They get whatever is suitable for mechanical recycling. So mostly PETs, they sort them out according to the color. And then what's left is usually used for incineration or landfilling. And so this is the leftover post the sorting plant. So you can see there's more than 60% of polymers, and there's quite a significant portion of non-polymer materials, so paper, non-plastics, and these all bring with them certain contaminants which are super dangerous in our standing in the big technologies in steam crackers. Let me just go back quickly to this number here. Just in a ballpark, for example, chlorine, which poses a big danger of corrosion in the technology, the inlet into the ethylene unit, which produces the plastics, the limit is around 3 ppm, super low numbers. And so we need to manage the contaminants somehow. So there's absolutely a need for technology that's capable of tackling such streams. And so we have kind of 4 pillars on how we approach chemical recycling. And let me just maybe add that pyrolysis is only one way of chemically recycling. Right now, it seems to be the technology with the highest, technological readiness level within the chemical recycling spectrum. But there are other solutions. Mostly, I'm talking here about pyrolysis. And so, coming back to the pillars we actually have to know the quality of the product. So we are developing, we have a huge background in analytics, in chemistry, and so we have ways of analyzing the final pyrolysis products to see how much cleaning they need before they can be introduced into the standing technology. The other pillar, of course, is the usability of the products, how they affect our materials. So, for example, corrosion in the most commonly used steels here. The other pillar is semi-industrial production. So we have let's call it a pilot pyrolysis unit with a relatively, small feed or capacity, 15 kilograms on the feed side. And we operate this to kind of optimize the whole process and see how we can maximize the yields of oil and optimize the process parameters, mainly temperature and residence time. So we operate this bigger unit, plus the last pillar is we actually do research in terms of new ways of developing technologies. We have a project that I'm responsible for, development of a multi-stage pyrolysis, which should tackle the problem of chlorine in the waste streams. And so I would sum this up as we need all these pillars. We need more R&D, we need the analytics, and we need, to see how these processes behave in medium and bigger scales to evaluate if they're viable. And the results we're getting seem to indicate that yes, this technology has future. And so just quickly, what's the vision for pyrolysis and maybe chemical recycling in general for the future? We need more investments and industry innovations. Improving analytical methods is something we work on every day. And by doing these, we can maximize the pyrolysis oil quality and quantity, and then introduce it into the standing steam crackers to produce polyethylene, polypropylene with a recycled content. And the more and more and the higher the technological readiness is, the higher the recycled content is going to be. And so companies or groups like Orlen, like OMV, like Shell, ExxonMobil, all the big players already are, announcing their industrial scale operations of these. And so that's the key here, that we are kind of already past. So pilot to industrial scales. The vision for example, Czech Republic could be having decentralized network of these small pyrolysis units. Producers of waste could process their waste, produce oil, transport it to refineries, much like ours, and we can produce plastics with a recycled content, getting to reduction of CO2 and using the waste streams more efficiently. And so that's the vision of the future. It's going to require the participation of governments, the industry, plus the consumers. Thank you.
Thank you, Daniel, for your presentation. But I have some questions for you as well. First of all, what do you think is the solution to increase the efficiency of recycling itself? Because if I remember right, it was less than 1% in your presentation. Is that right?
Yeah, so overall recycling was around 14%, and less than 1% was chemical recycling. So we need to work on both. These two should work in conjunction. They should not, so to speak, cannibalize off of each other. And it's going to work that way because for mechanical recycling, we're used to it. You have the polymers like PETs that are suitable for that, and they're kind of unsuitable for chemical recycling. So it's a perfect situation. Now, to your question, there's maybe two pathways here. Us as consumers, what we can do is being more responsible with how we recycle. Honestly, even me working on chemical recycling, many times I find myself throwing some little, something into the yellow bin that's not supposed to be there. And from the graph I showed, the composition of the waste streams, this is a big problem. So there's paper, there's glass, there is metal in the yellow bins, and it just shouldn't be there. So the consumer, ourselves, what we can do is be more responsible. We can look to Scandinavian countries and how they behave. So the behavior there is a little more responsible. That's going to help. Maybe the second stream is getting these technologies I talk about to higher efficiency, and that's something that's ongoing. And so we can do that. Plus, maybe I would say the waste, processing companies will be investing in their sorting lines, but that's going to take some time. So they're coming up with new technologies, including or involving algorithms or AI for automatic sorting of different plastics. It's quite amazing what they can actually do, but it's going to take a couple of years before they get to industrial scale. So these I would say are the keys to improve the efficiency of recycling.
Okay. What is currently the biggest challenge for the development of chemical recycling?
I would say the difficulty with the waste streams. So I mentioned it in a couple of slides. There's just too many, the streams are too contaminated, and most technologies that we see being developed are focusing on quite pure polymer waste streams, mostly from the industrial waste, because there you will not have many contaminants. If you have a company producing polyethylene, polypropylene products, they do have waste that's just going to contain that and not many contaminants. With the post-consumer waste, however, you have just too much contamination, and so it's just going to take investments and the effort in the research to tackle these streams and clean the oil so much that it can get introduced into the standing technology.
Mm-hmm. Is there not currently a technology that can cope with even waste streams challenging as the one you mentioned in your presentation?
Right. So as of now, as I mentioned, we are what we do with the streams are burning it. So you can essentially burn whatever. So we have to move on from that. We are looking into plasma gasification, which is one way of tackling difficult waste streams. But in terms of using or creating new products, I think chemical recycling is going to have to tackle this. And as of right now, there is no technology that would be capable of processing such contaminated streams. But we are working on it, let me assure you. So hopefully in the upcoming years, the technological readiness is going to be there.
Okay, thank you, Daniel. Any questions from our panelists or guests?
I will have one, please, if I may. My question is towards legislation. If Daniel is also dealing with this issue, because for us, because we are both in recycling area, is if it is this problem and where it is heading, because it was quite a huge problem some years ago when I was discussing it with my friends to put somewhere the pyrolysis unit. It's quite difficult. So if you have something on this, please.
Yeah, absolutely. So we're working on talking to the policymakers, to the politicians about this, because as of now, for example, in the Czech Republic, the legislation doesn't know the term chemical recycling. So what they know is the mechanical recycling, and then they tell you, or you tell them, I can use the stream and upcycle it. So as I said, so you can have a valuable product out of it. So you can produce the oil and get new plastics out of it. And they ask you, okay, why are you not using it the traditional way, the mechanical recycling? And it's kind of a vicious circle of you trying to explain that this method is more efficient, but the legislation just doesn't know it. So if you don't mechanically recycle, you don't recycle at all. That's how the legislation looks at it. So there is absolutely a need to change this. But I understand that it's a little difficult to explain the efficiency of these processes on the policymaker level. But the answer, maybe not the one you were hoping for, but it's going to take legislation change to move on.
Okay, thank you, Daniel, for your answers and for your presentation.